All right, let's get right into it. Today, we are talking about one of the most elegant, most foundational algorithms in all of distributed systems. Seriously, this is the secret sauce behind huge services like Amazon's DynamoDB, and really countless others. This is the invisible engine that makes the internet scale. Now, if you remember our explainer from day 8, we went deep on caching, storing data in faster memory to speed everything up. But what happens when your cache gets so big it just can't fit on one machine anymore? How do you scale it? Not just a little bit, but like to infinity. Well, it turns out the most obvious common sense solution for spreading that data out has a catastrophic flaw. A flaw is so bad it can bring your entire system to a grinding halt. And to really appreciate the genius of the real solution, we first have to understand the disaster. So let's set the stage, right? You've got a ton of data and you've got a bunch of cache servers. The question is, how do you decide which piece of data goes on which server? You need a simple, reliable rule. And the simplest rule in the book is the good old modulo operator. You just take a hash of your data key, you divide it by the number of servers you have, and whatever the remainder is, boom, that's your server number. It's like a sorting hat for your data. Super simple, totally predictable. And you know what? When everything is stable, it's actually beautiful. Look at this. It's a perfect little world. We've got our 4 happy pulsing server boxes. Glowing orbs of data fly in, the modulo operator does its thing, and every piece of data lands exactly where it's supposed to. The load is balanced, the system is fast, life is good. But what happens when this perfect world gets a dose of reality? What happens when a server goes down for maintenance, or when we need to add a new one to handle more traffic? This is where our simple, elegant system turns into a ticking time bomb. And boom, server 1 goes offline. Our cute little server box suddenly gets an angry red face and powers down with a sad little zap. So now we only have 3 servers. And you might think, okay, no big deal. The other 3 will just pick up the slack. But you would be so wrong. This single failure is about to trigger a system-wide catastrophe. And this quote just nails the problem. When n, the number of servers, changes, the math breaks. It breaks completely. The remainder of a division problem changes entirely when you change the thing you're dividing by. And here's what that chaos looks like. Our formula flips from hash%4 to hash%3. And suddenly, nearly every single key maps to a totally different server. The data orbs start flying around like crazy, your cache becomes almost useless because every request is a cache miss, and all that traffic stampedes directly to your database, completely overwhelming it. Yeah, that number is not a typo. When just one server goes away, or you add a new one, almost 99% of your keys get remapped. Your cache is effectively useless in an instant. This is the rehashing problem, and it is an absolute nightmare for any large-scale system. Plot twist. What if we've been looking at this all wrong? We've been lining our servers up in a row, like numbers on a number line. Fragile. What if we arrange them in a circle instead? And this brings us to the hero of our story, consistent hashing. This is a total paradigm shift. Instead of that fragile line of servers, we're going to create a resilient ring. Okay, so here's how it works. Step 1. We imagine this abstract circle, a hash ring. We take each of our servers, we hash its IP address or its name, and we place it at that specific point on this beautiful glowing neon ring. Next, we do the exact same thing with our data. We take a key, run it through the same hash function, and bam, we place that glowing data orb at its own unique spot on the very same ring. So now our servers and our keys are all living together in this circular space. So how does a key find its home? This is the crucial part, and it's so simple. The key just travels clockwise around the ring until it hits the very first server it finds. That's it. That server is its home. No more modulo math, just a simple directional rule. Go clockwise. So now let's replay our disaster scenario on the ring. Okay, one server box disappears, but look what happens. Only the data orbs that were assigned to that specific server are affected. And what do? They just calmly continue their clockwise journey until they find the next available server on the ring. And all the other keys, they don't move, they don't even know anything happened. And that is the absolute genius of this design. Instead of a 99% system-wide meltdown, only a tiny fraction of keys have to move. The blast radius is contained, the system stays stable, it stays responsive, and calm is restored. Okay, reality check. The ring is a brilliant idea, but it's not quite perfect yet. There's a subtle flaw. See, hashing algorithms are great at creating a random distribution, but random doesn't always mean even. Hey, do you remember from our Day 13 explainer on sharding? We talked about the Justin Bieber problem, where one database shard gets absolutely hammered with traffic? Well, the exact same thing can happen here. Just by random chance, all your servers might clump together on one side of the ring, leaving one server responsible for a huge chunk of data, while another one is basically doing nothing. So how do we fix this? How do we smooth out those random clumps and prevent these hotspots from forming? Well, we add one final master-level refinement to make this thing truly production-ready. And that final polish is an idea called virtual nodes. This is what takes consistent hashing from a great idea to an industry standard. Just look at the difference here. On the left, you see that hotspot problem. One server is flashing red, totally overloaded, while another one is just sitting there, bored and sad. On the right, you see the fix. Instead of putting one physical server on the ring, we pretend it's, say, 200 smaller servers. These are the virtual nodes. We scatter these hundreds of little color-coded dots all around the ring. Now the data gets distributed much more evenly, which means the load on our actual physical servers is beautifully balanced. So let's just quickly recap our journey. We started with a simple but super fragile system using the modulo operator, which caused a catastrophe anytime a server changed. The solution was to change the shape, the geometry, from a line to a ring, which brilliantly minimized data movement. And the final refinement, the final polish, was adding virtual nodes to make sure the load on that ring was always perfectly balanced. And that's consistent hashing. It's just a powerful reminder that sometimes the most elegant solution to a really complex problem isn't more complexity. It's just a fundamental shift in perspective. It really makes you wonder, what other obvious ideas in tech are just waiting to be completely reinvented?